Hey guys, today's problem is kind of similar to the problem we done before. That problem is the disappearing numbers in array problem, where we use some smart indexing, smart masking to reuse the array that we are given as an input to find the numbers that have disappeared from the array. We will do something similar to that in today's problem too. So the problem name is find all duplicates in the array. We are given an array nums of length n, and all integer of nums are in the range 1 to n. This is probably the most important information from the problem. Each integer appears once or twice, and we have to return an array of all integers that appear twice. We also have to write an algorithm that runs in linear time and also doesn't use any extra space, so it's a constant space complexity. So we cannot really use a hash map or set or helper array to find out the duplicates. We have to somehow reuse the input array. And if we go through the examples, in the first example, we have 3, 2, 2, 3, which are reappearing. So they are duplicates. All other numbers are appearing only once. So we just return 2 and 3. In the second example, we have the first two numbers are the same. We have 2 ones, and then the last number is 2. So we just return 1 because we have a duplicate of it. And in the second example, we only have one number. So there's no way that we can have a duplicate. We just return an empty array as our final result. So in the constraints, we again see that each element in nums appears only once or twice. And the length of the array will be from 1 to 10 to the fifth. But again, the important part is this, that each element in the array ranges from 1 to n. When you see this, you can almost immediately think how you can map the current number to its index, because we know that we will have valid indices because the numbers are ranging from 1 to n. If you, for example, had numbers ranging, like this constraint didn't exist, you had numbers like 10,000 and you had only an array of 5 elements or something, you wouldn't be able to find the index of this number. You wouldn't be able to use the index of this number to somehow, in a smart way, to declare the nature of the number. Is it appear twice? Is it appear several times, and so on? And to make things clearer, we will just go through the example. Here we have our input, and we will operate on, this is not a new array, it's the same array given to us as an input, and we will operate on the initial array. So we know that the numbers are appearing once or twice. So if we somehow can use that fact, we would be closer to solving the problem. Because they are appearing only once and twice, maybe we can first find the corresponding index for each number and mark that value as negative, because we know that numbers are from 1 to n. So initially we will not have any negative numbers, and all numbers will give a valid index to the input array. So example, if an element is equal to 1, the index will be 0. You remember that to find the corresponding index, we just decrement by 1. And so the next time that we face the same value, we will visit the same index, but then we will see that the number at that index, the element at that index, is negative number. So we know that we have already checked this index, which basically means that we have already encountered the same number that maps to that index. So this is our second time, which basically means it's a duplicate. So let's just go to an example. We have 4 here. We start with 4, and the corresponding index is again 4 minus 1, which is equal to 3. So we see that the number currently is 7, which is a positive number. So we know this is our first time that we are checking the number that's corresponding to this index, which is our number 4. So we will make this number negative. Now we will go to the second number, 3, and the corresponding index is 2. So we will make this, and again, it's a positive number, so we are seeing the number 3 for the first time, and we are going to make this number negative. Next, we go to the number 2. Again, the same story. We will match it to the index 1 and make this positive number. We are seeing number 2 for the first time. We will make this number negative. Now we will go to number 7, now our next element in the array, which corresponds to the index 6, which is again a positive number. So we will just make it negative. Now we will move to the number 8. Again, it's a positive number, index 7. 8 minus 1 is equal to 7. So we make this number negative. Now we go to the number 2, and that number will match the index 1. But we now see that this number is negative. So we know that it's not our first time that we have encountered number 2, because this is our second time that we are checking the index 1. So in our result, we will place number 2 as the first element that has duplicates. Now, you see that the array is being modified, and I used the initial values for the array just to make the approach simpler to explain. When we go to the next element 3, it's not longer number 3, it's -3 now, because we changed it because we checked the number index 6 because we encountered number 7 here, and we had to make it negative. So to find the corresponding index, it will not be enough to just decrement the number. We would have to find its absolute value. So instead of like doing -3 minus 1, which will correspond to -4, which is out boundary index for the array, we will do absolute value of -3 minus 1, which is equal to 3 minus 1, which is equal to 2, just as we would have the number 3 in the initial input. So this would match the index 2, and we can see that we have a negative number. So we know again that this is our second time that we are seeing number 3, so we will add it to our result. And the last number is 1, which corresponds to the index 0, but here we have a positive number, so it's for our first time seeing this number, and in this case we are at the end of our traversal, at the end of our array, and we can return the result 2 and 3 as our final result, and 2 and 3 number as numbers that have duplicates inside the input array. The space complexity is constant because we haven't used any additional data structure, and for time complexity, we have linear time complexity that's proportional to the length of the input array. Let's solve the problem using Java programming language. First, we will declare our result, which is just basically a list of integers that we will return as the result of the function. Next, we will, just for readability purposes, we will just declare n as our length of input array. We will traverse through our array, and each time we will get the index by first getting the absolute value of the current element that we are at, because it can be a negative element in case we marked the current element negative, because a number that corresponds to that index occurred once in the array before we reach this element. And then the last step would be to decrement that absolute value by 1 to find the corresponding index. And then at that corresponding index, we check if the number is already negative, which means that it's our second time that we are checking this index, which basically means that it's our second time that we are seeing the number that corresponds to that index. So we would just, in that case, we would just add it to our result. And we do a reverse operation to get the number that corresponds to the index. We just increment the index by 1. In the case the number is not negative, we make it negative by just multiplying by -1. at the end, we just return the result.